Beautiful. Let's make sure we started.
After lunch. I remember even though like absolutely nothing during the cycles has been.
Oh, yeah.
Yes, you would.
All righty.
I don't know what I'm doing, just answer questions.
Density curves and normal distributions. Normal distributions are something that is beyond, please understand the categories. If that can kind of make any sense at all, please understand categories. If you do not understand normal distributions, we're in big doo-doo all year. So normal distribution, we'll talk about density curves for just a little bit, but a normal distribution is a density curve, it's just a special one. I don't know how much of this you really need to write down, truth be told. I'll try to make sure I emphasize. I do not know that person. Hopefully you can use a density curve to model quantitative data. Hopefully you will be able to identify the relative locations of mean and standard deviation. I think we've already discussed that once, how the mean is kind of pulled to the skewness. Use the empirical rule to estimate the proportion of values in a specified interval. So the empirical rule is something that's really big. Find the proportion of values that fit in the normal distribution using table A or technology. I do not use table A very much at all. I use technology. I will teach you technology. If you want table A, you'll pretty much have to use that on your own. Find the value that corresponds to a given percentile by using table A or technology. Again, I will show you table A, but we use technology more than anything else. Okay. All this stuff we did already. In fact, I think I put it on your notes. Always plot your data. You've got to plot your data so we can have an idea of what to use it for. What to use, the mean or the median or the standard deviation or the IQR, depending on what the data looks like. Anytime it's skewed, you really should use the median and the IQR. If it's symmetrical, you should use the mean and the standard deviation, although we did learn that the mean and median are somewhat the same in a symmetrical distribution. Look for the overall pattern, so we'll look for the shape, center, spread. Calculate the numerical summaries, yada, yada, yada. And then when there is a regular overall pattern, we will model it with a density curve. And that was the last one that we're going to look at. When there's an overall pattern, we're going to model that with a density curve. Again, you won't be asked for what is a density curve, but they will say something like, use the density curve. You just need to know what it means. And a density curve basically follows the data. It makes it continuous. It makes it a smooth, basically, function, if you will. Well, there were a lot of people writing right there. Backspace. I don't know how much of that you need, if any, but. Oh.
You ever pointed at a plane?
What's that?
You ever pointed at a plane?
At a plane?
Yeah.
I have not.
Are you just lying so you won't get targeted by like, the
no.
FBI? No.
It'll take it out of the question.
You can plead the fifth.
No.
No.
I messed up with my cat one day. That was fun. Stupid cat, I hate that thing. Crap, that's on film. I'm just kidding, honey. All right, we're good? All right, density curve. A density curve is one that just basically follows the trend of the data. That's what it does. It follows the trend of the data. So you kind of see the bar graphs or the histogram, whatever it might be. If it's somewhat skewed to the right, then that density curve is just going to kind of somewhat follow it. It won't fit perfectly, but it's going to come close. It follows the curve of the data. That's all it does. It's always above the horizontal axis. It will never go below the horizontal axis because that would be negative information, and we do not deal with negative information in statistics. Has the area of 1 underneath it because 100% of the data will fall underneath that curve. So it has an area of 1 underneath it. And then don't write any of that crap down. The area under the curve, above him, oh. This is in words. I couldn't really figure out how to say that in words. the area between 2 points, that's probably how I should have wrote it. The area under the curve and above any interval. Above interval, below that, on the horizontal axis, estimates the proportion of observations that fall between these two values. So the area that falls between those two values above that line is the proportion that will fall between that, which I hope kind of makes more sense than that statement does right there. It's 100, if this is 1 and this is 8, that's 100%. So if it just goes between 2 and 4, that's whatever proportion that is. So the area under the curve above an interval on the horizontal axis, that's probably, I should have taken that part out, estimates the proportion of observations that fall in that interval. Not that big a deal. I think the wording is more confusing than just knowing it. I see a couple squinchy looks. Hopefully, by the time we get through a couple slides, you'll be fine. That distribution looks somewhat, you could say symmetric, but there's even more, something that describes it a little bit better. Uniform, straight across. Y'all okay with that? Symmetric will describe it, but I think uniform describes it better. It's somewhat straight across. There might be a little dip in between there, but above all, it's pretty straight across. So that's the data, that's the dot plot. It says journey time. I don't know what the journey time was. It was 2 minutes to 5 minutes, I guess. That would be the density curve of it. That would be the density curve, and it goes from 2 to 5. Y'all okay with that? Easy enough? Density curve. I don't know why it's 2 different colors. Apparently I'm just doing something else where I copied it. My question to you is, why is the height of that density curve 1/3? Because on the test, I'm going to give you one, and I'm going to ask you, what is the height of the density curve? And it happens to be uniform. What's the area underneath that curve? 1. So what's the length of that? This is 2 and this is 5.
3.
So that's 3. So if the area is 1, then that height has to be 1/3, because the area underneath a rectangle is length times width. Kind of okay with all that stuff? Question on the test is going to be just that. Find what is the height of this density curve? And I think it's a rectangle. I think it's a rectangle. That's pretty easy. If it's a triangle, it takes a little bit more to try to find it, right? I think I give you a worksheet one that asks you for some things on that. So what proportion of the times are between 4 and 5? Well, between 4 and 5, that's 1. That's 1/3, so 33% of the data falls between 4 and 5. Kind of make sense there? Between 2.5 and 3.5, that's 33%. So between the two values, and that's what we're doing over here, between the two values is the area underneath the curve between those two. Is the proportion of times that it can happen. Between 2 and 5, 100%. Okay, everybody's written down what they need to on that. Questions? Again, the density curve doesn't fit exact, it's close. You can see that some of the rectangles are outside of the density curve and some of them are inside. It just comes close. It doesn't have to be perfect. Just like in this uniform, you would not do a density curve and make it look like a 15th degree polynomial. Makes sense? You just draw it straight. Whoops, this way, okay? We've already discussed this. I think this was a couple chapters ago. In a symmetric distribution, the mean and the median are pretty close to the same. Okay? In a symmetric distribution, the mean and the median are pretty much the same. In a skewed distribution, that pulls the mean. And so in this particular distribution, the mean will be higher than the median. Remember that if the mean is higher than the median, that does not mean it's skewed. But if it's skewed, that means that the mean is higher. So one of those ways it goes, the other ways it does not. That's old news. The mean of the curve, the mean is where it would balance. So picture this stuff as a balance scale. The mean is where it's going to balance. The mean is where it's going to balance The median is where it's gonna divide it up into 50% and 50%, which is different than the balance point. The median is gonna be 50%, 50%, the mean is gonna be the balance point. That just helps you decide on where they're going to be. At some point, I'm gonna give you a test question, and I'm gonna give you a skewed data, and I'm gonna label 3 different lines. And I'm gonna number them 1, 2, and 3. And I'm gonna ask you which one of these is the mean, and which one of these is the median. And the third line is nothing. The third line's arbitrary, like it doesn't make sense for it to be the mean or the median. Typically, students do very well on that question. Any questions about that? Again, this is old news, just kind of re-emphasis of that information. Some pencils are going, let me slow down. Nothing really important yet. Nothing really, really important yet, but hopefully this information's old. You okay? All right. No COVID, I hope. Good. Not funny, but it, some of it is sometimes.
What was that?
What's up?
Did you have any sapling homework like due?
I mean, not really.
Oh, yeah.
It didn't shut off.
When does it shut off?
I don't know.
29th.
There you go. I just made up a date. We already said that. Okay, here we go, normal distributions. One particularly important family of density curves are normal curves, or normal distributions. Very, very, very important to talk about these, okay? Shape. All normal distributions have the basically same overall shape. They're symmetric, single peak, and bell shaped. They start low, go high, go low. Start low, go high, go low. They're bell shaped. Pencil. I want this. This works better. Oh, back. Oh, nope. I didn't turn it to a pen. Here we go. Start low, go high, go low. They're symmetric, single peaked, bell shaped. Okay? The mean is usually located at the midpoint. Depends on if we're talking about a sample or the population. The mean is right at the middle. The standard deviation is, I don't really care where you put the standard deviation, but just know for some of you guys that have done calculus or done some big time mathematics, a parabola or a curve, this is somewhat a parabola, it's not really a parabola because it does open it up, but all curves at some point turn from what we're going to call concave down to concave up. And so they call that a point of inflection. Just kind of some big time information that some of you care about and some of you don't, but I'm a nerd with mathematics and I love it, so I'm talking about it. Anyway, wherever that point of inflection is the one standard deviation. You don't have to be exact, as long as you're close, that's one standard deviation. One standard deviation. So if I draw this like that, that's still the middle, but that one standard deviation is a little bit less than this one. What's the area underneath the curve? 1. So the standard deviation of this one is more than the standard deviation of this one. Kind of makes sense there. 1 standard deviation. Again, you don't have to be precise, you don't have to be accurate, just close. Just close. The standard deviation measures the variability or the width of a normal distribution. That's all we're saying right there. That's more information than you would ever want to know about a normal distribution. Everybody good? Quick. There are 2 different normal curves. Here's mu, here's sigma. Here's mu, here's sigma. If these were on the same number line, this mu would be a whole lot bigger than this mu. If they were on the same number line, because if this is 2, then this would have to be like 5 or 6 or 7 or 8. That distribution width, or that width, standard deviation is a whole lot less than that one. Write down what you need to on that, but it's not that big of a deal with statistics. You just need to understand that the mean is in the middle and the standard deviation is some width apart from it. And when you understand percentages, or after the empirical rule, that will make sense a little bit with these widths. You'll get pretty good at drawing these standard deviation, or the normal curves. And if you don't, it doesn't really matter. You don't have to be, if it looks like that, I don't know what's wrong with this thing jumping like it has been lately. They are beautiful. I'm pretty good at them. I've been doing it for 15, 20 years, so. Everybody okay? Anything about a normal curve so far? Just a normal curve. Means in the middle, standard deviation is basically the width of it. Not the width of it, but it helps us define it. A normal distribution, symmetric, single peak, bell shaped, called a normal curve. Any normal distribution completed mean standard. That's all. That says the same thing what I just talked about. These are defined by the mean and the standard deviation. If I tell you the mean is at 6 and the standard deviation is 8, that tells you something different than if the mean was 20 and the standard deviation was 1. That would tell you it's more narrow than the previous one, and it's to the right of it. Normal distributions are really, really important in statistics. You don't need to write any of this stuff down, you just need to know it. But they're really, really important in statistics. Normal distributions are all over the place on us, right? Scores on tests, not tests as in this class. Hopefully these are really skewed, right? That's what we would like, all the 100s and none of these low ones. But SATs, IQ tests, typically those are normally distributed. You have an average that most people get. Some get a little bit higher, but more of those get a little bit higher than a whole lot higher. Some get a little bit lower, but more of those get a little bit lower than a whole lot lower. I think I'm going backwards on you guys. Repeated careful measurements of the same quantity. So if I'm measuring the diameter of a tennis ball, right, and I ask every one of you guys to measure the diameter of that tennis ball, not everybody's going to have the exact same number. Good morning. Fine, thanks. How are you doing?
Good, how are you?
I told you, I'm doing good.
Bye.
Peace out. What'd you do?
Where am I going?
I don't know.
I don't think you're.
I asked you don't think you did anything? Oh, good. It's not for you.
Did you participate in that devious lick challenge?
There's no mirrors in the bathroom.
Stupid kids. Silly
They
beavers.
took out the mirrors.
Should I go?
Whenever it's convenient, whatever you want to do, hon.
Okay, I'll wait.
It says when convenient.
It's never convenient.
It's never convenient for me. That's what I said. Don't ever put that on me. Okay. So if you all measure that tennis ball, right, I don't think everybody's gonna measure it exactly the same, but most everybody's gonna be pretty close to what the average is. Some are gonna be a little bit higher, some are gonna be a little bit lower. If you're a whole lot higher, you're gonna be in the minority. Kind of follow that anyway. Biological populations, length of crickets, height, shoe size, so many things out there in this world are normally distributed. Normal distributions are good approximations to a result of the kind of chance outcomes, like proportion of heads in many tosses of a fair coin. If I toss a coin 10 times, I should get 5 heads, but I won't always get 5 heads. Sometimes I'll get 4, sometimes I'll get 6. But to get 10 heads would be very, very unlikely. To get 0 heads would be very, very unlikely. So as I get closer to the middle, it becomes more likely that I'm going to get it. Anyway. Everything that we're going to do in chapters 8 through 12 are going to deal with a normal distribution, and that's why I say it's very important for you to understand normal distributions. Here's the empirical rule. This is really, really important to know. So the empirical rule breaks a normal distribution up into percentages, and it's called the 68, 95, 99, 7 rule. And you will have those numbers memorized before the end of this year, pretty much a guaranteed. Even if you don't want to memorize them, you'll have them. So what it says is in a normal distribution with some mean and some standard deviation, it doesn't matter what the mean is and it does not matter what the standard deviation is, 68% of the data will be within one, that's just a single, standard deviation of the mean. 68% will be within one standard deviation of the mean. So if I draw a normal curve, there's the mean, there's the standard deviation. That will be 68% of the data. Now, my graphical representation is probably not very good because that does look like it's more than 68%. Because I probably did not draw it at one standard deviation exactly. That one is. It actually says 68.3, but we go ahead and just round it to 68. Notice that the center is at 0, and that is 1, and that is negative 1. 68.3, again, we'll just say 68%, is between positive 1 standard deviation and negative 1 standard deviation. Empirical rule, 68%. 1 standard deviation. The empirical rule is also called the 68, 95, 99, 7. So the 95 probably means that 2 standard deviations are within 95% of the data. So in a normal distribution, if you're within 2 standard deviations, you're a common 95% of the data. So if the average height of individuals is 6 feet and the standard deviation is 5 inches, then 95% will fall between 5, 7, and 6, 5. I'm making all these numbers up, but except for my answers. So 95 fall within 2 standard deviations. So again, if I wanted to draw that, there's 1, and now this distance should be the same. They should be the same. 1 standard deviation is the double, or half, I guess I should say, of 2 standard deviations. So if this is 1 and this is 2, all of this data, I didn't do a very good job of drawing it. 95%. And so that has to mean if it's 90, 98, 95, and 99.7, then 99.7 will fall within 3 standard deviations. So almost all of the data falls within 3 standard deviations. There is a very, very small amount that falls outside of the 3 standard deviations. So if you want to really insult someone, you tell them that you're 4 standard deviations below the average intelligence. Because you're pretty darn dumb. I should never ever tell you to do that, but that kind of makes sense, right? I don't know if intelligence is on a normal curve, but I think it is. Yes, sir.
So this only works for normal distribution?
Only works for normal distributions. And that's getting ready to pop up at some point. If it's a uniform distribution, that's not 68%, 95%, 99%. It only works for normal distributions, and that's very, very important for you to make sure that you get. Here's a picture of it. This is one that's actually drawn out mathematically correct. What the deal is, guys, is we don't know calculus. Maybe some of us do, but we can't find the area underneath curves. If it was a uniform distribution, we can find the area underneath the curve between those 2 points because it's just length times width. If it happened to be triangular shaped, I could find the area because it's 1/2 length times the width, unless it ended up being a trapezoid. But this curve here, we can't figure out the area underneath it. So, because of that, I'm just telling you the area between here and here is 68. And the area between here and here is 95. And the area between here and here is 99.7. Just say I get to you, thank you. So let me ask you this, do I have a blank one? No, let me do it from here. That's one standard deviation, negative one. Here's 0. Y'all okay with that? How much area is there? 34. Fair enough, half the 68. How much area? Oh, shucks. Well, that's purple, we don't ever use purple. How much area is that?
How many deviations is it?
So this is still 1 right here.
The whole thing?
So just the blue,
Oh,
just the blue.
it's 1 or 2 maybe?
17, actually 16, I think. 68's the middle. Y'all with me? So that leaves 34 left over. And if it's 34 left over, this has to be half the 34, and this has to be half the 34. 32. Sorry, which gives me 16. That's what I get for guessing. Y'all okay with all that stuff? If it's just, let's make an easy one. Let's make this one easy. Green. How much area is that? 50%. Easy enough there? 50%. So some of these, now that we know the empirical rule, we don't just know the middle, but we kind of know some other ones. And so, and because it was 95, we know some other ones. Okay? So how much is greater than 3 standard deviations? Greater than 3. Well, all of this is 99.7. So that leaves 0.3 left over for both ends. So 0.15? Okay. Yeah, 0.15%. Okay? Good. Beautiful. Again, just another picture of it. When you draw one of these guys, you do not have to draw them accurate. You don't have to draw them perfect at all. Just get close. Just get close. And then this is what Mr. Kellen just decided. The empirical rule only applies to normal distributions. Only applies to normal distributions. So please do not use the empirical rule for anything else other than a normal distribution. And I'll get you on the test on that. Because you guys are so used to using normal distributions, and I tell you on a test, this is a uniform distribution. And most of you are going to use the normal distribution stuff for it. Okay? So just be careful of that. Be very, very careful. All right. The standard normal distribution does this. It puts this at 0 and that at 1. The standard normal distribution uses a mean of 0 and a standard deviation of 1. Uses a mean of 0 and a standard deviation of 1. So this value right here is 1. This value right here is -1. Then I got -2. And I got positive 2. Okay, so that's the standard normal distribution, or what you guys, or what we might call now, is a Z distribution. So the standard normal distribution is the same thing as a Z distribution. Okay? Because we become lazy and we don't like writing standard normal, so we'll just call it Z. Any questions about that? The reason why we have a standard normal distribution is because of the table in our calculators. Our table in our calculators can calculate the standard normal distribution, but we can't do it for other ones. So we have to convert, listen to me, we convert everything to a standard. Because a lot of times we don't want to just know exactly one standard deviation. We might only want to know like half a standard deviation. Well, we can't find the area for a half a standard deviation, and it doesn't fit the empirical rule. So we have to use calculus. Well, we don't know calculus, so we're not going to use calculus, so we have to use calculator or table. Click, here we go. This is how you're going to find the area underneath 2 points. Every single time you must do these things. If you do not do these things, you will not get the E. Now, if it's multiple choice, you don't have to do any of these things. Please understand that, right? But if it's open response, you must do these things in order to get the E. So the very first thing, you're going to draw the normal distribution. Draw it. Doesn't have to be beautiful, doesn't have to be perfect, just draw it. Draw it. Don't write all this other stuff down if you don't want. Horizontal axis labeled. Scale it using mean, standard deviation, boundary values. Don't write all that stuff down. You just want to draw it. Draw it and put the mean and the standard deviation on it. So you're going to draw it. You're going to put whatever the mean is, and you're going to put whatever the standard deviation is. Okay? So if we're talking about heights of males, we're going to put this at 60, and we're going to put this at, I forget, 2. I'm making that up, but I'm pretty close. Oh, shucks. I can't double erase. That's funny. Okay, draw it. After you draw it, we're going to perform the calculations. In other words, show your work. Show some kind of work, something. Your calculator, I'm telling you, will do everything for you. But if you let your calculator do everything for you, it will not get you any points at all. Because that does not tell the grader that you understand statistics. It tells the grader you know how to use your calculator, but it doesn't tell the grader that you understand it. And there is a difference. We don't care that you know how to use your calculator. We care that you understand it. In fact, you can explain it and get the wrong answer and still get full credit, as long as it's explained correctly. But if you get the right answer and you don't explain anything, you will not get any points. Makes sense there, you okay? Making answers. But your calculator will do everything, but you just got to show the correct calculations. Show your work, whatever it might be. And I'll show you, when we do my example, I'm going to show you guys what to expect. Okay? It's not much. It doesn't take much to do this. It says do one of the following. Standardize it using table A or use technology. Again, you don't need to write that stuff down. This is going to be pretty explainable. And then make sure you answer the question, guys. Make sure you answer the question that was asked. Sometimes we get so involved in what we're thinking we're supposed to do because we kind of get robotic. That's the process of mathematics, right? We give you an example and you do 15 of them the exact same way. Well, the same thing here. You're going to do one and you're going to do them all the same way. But sometimes the question is different. Just make sure you answer the question. Make sure you answer the question. Here's our example. Why will that not go away? Okay. Stop. Good cheat. Pen. The distribution of ITBS, Iowa Test of Basic Skills. I think we used to take this one actually. Vocabulary scores among Gary, Indiana 7th graders. Recall that this distribution is approximately normal. Boom, I'm going to draw it right then as soon as it says that. I'm going to draw it approximately normal. I'm not going to try to put that little hiccup in it. With a mean of 6.84. 6.84. Standard deviation of 1.55. Go back to chapter 1 when I told you very seldom are you guys going to have to find this information. Most of the time they'll give it to you. What proportion of the 7th graders have a vocabulary score that are below 6th grade level? So this is what I'm going to do from here. Where's my pencil? Let's turn it to green. Oh, shucks, go back. So here's, let's see, 6.41, that's 5, so 6 is going to be somewhere in here. You don't have to even be close. It doesn't really matter. 6. Fair enough of what I'm doing. And then I'm going to color that in. Question? Good? And then I want to write my statement. This is a little bit new. This is something that I require. I don't know how well AP does it, but I think it makes sense and it will make more sense to you as you progress. Big P means the probability of. Big P means the probability of. So this says right here, what is the probability that my value will be below 6? Okay? Fair enough, we all kind of follow along. What is the value, what is the probability that the value will be below 6? Now I know that this is 6.84 and the standard deviation is 1.55. So if I subtract 1.55 from 6.84, I'm gonna be more than one standard deviation away. That will be one more. So 6 is less than one standard deviation away. So I can't really use the empirical rule because it doesn't fit the 1, 2, 3 category. Okay with all that? So here's what I'm gonna have to do. I need to turn this value into a standardized score. I need to turn it into a standardized score. We don't call it a standardized score, we call it a z-score. And we kind of did that in 2.1, but we're gonna do it a lot here. So first thing I wanna do today is turn that into a z-score. So I've done part 1. I've drawn it, I've written the statement, I've done everything I wanna do for part 1, now I gotta show my work. Okay, so here's where I'm gonna show my work. I'm gonna just say z equals 6 minus, because it's the x value, minus the mean, divided by 1.55. This is what we did yesterday, or the day before, or whatever. And so now I have to find the z-score of that. And now that's where you use your calculator and you'll do 6 minus 6.84 and divide it by that. Be careful. Some students will do 6 minus that and not hit enter, and others divide. Be careful, right? Because that'll give you the wrong answer. You know that your calculator is doing the order of operations. So draw the normal distribution, we did that. Is anybody writing? Am I still okay? Draw the normal distribution, we did that. Okay, now what I gotta do is figure out what that number is. Anybody got that? 0.54, sweet. Negative 0.5, because it's definitely gonna be negative. Because the z-score, this is 0, fair enough? So really what I'm doing is I'm converting this normal distribution into the standard normal distribution, which puts the mean at 0 and the standard deviations at 1. So it's negative 0.54. Really, really, really good students will now do this. Ooh. Oh, that's a negative. Y'all see that? This is asking the exact same question as this. That's less than. I don't care which one of those you write, you do not have to write both. But somehow or another, you gotta convert that 6 into a z-score, and that's the work you gotta show. And once you do that, that's the only work you gotta show.
So that's our answer right there?
Well, we're getting ready to have to find it. So we're gonna have to use our calculator or use our table to find the answer. Okay, because this is my answer over here. I haven't found the proportion yet. I have not found the proportion yet. All I've done is convert it to a z-score. And I have to convert it to a z-score in order, 1, to show my work and get full credit. And 2, in order for my calculator, not really, I'm lying. Your calculator will do it without it. But in order to use the table. Draw the normal distribution. Perform the calculation to show your work. And I already showed you this is the only work needed right here. This is it. That's all that's needed. Okay? That's all that's needed. Table A. Oh, that's not going to work because this is now a marker. I thought that was supposed to be an arrow. Can I turn it off? Oh, yeah. Sweet. Here is table A, which is in the back of your book, or it's on internet, or you can find it. Here's a z-table score. They're all the same. They're all the same. Over here's your z-score. Negative 3.4 is the smallest one, because you know that after 3 standard deviations, you're getting really, really small anyway. And so these are all the negative z-scores. What was ours? Negative 0.54? 3. Oh. So I just need what? Negative 0.5. Here's negative 0.5. That's 0.50, 0.51, 0.52, 0.53, 0.54. Y'all kind of see how that table went. And now that's the percentage. Where'd it go? 0.2946. 0.2946. So you gotta find the z-score over here. Now the positive z-scores, guess what? Guess what? Positive, never mind, I shouldn't do that yet. I'm not gonna do that yet. I get too busy as you guys are learning. So negative 0.5. 0, 1, 2, 3, 4. And you can see up at the top it says 0.04. So that's the z-chart, or table chart, or whatever you want to call it. 2946. Go back. Here, here. Pencil. Back up, pencil. Where are we at? Pencil. Where are you going? There you are. Whoa. What was that? I'm here. I'm good. Oh, I'm going way too far. There it is. Okay, here we go. Sorry. 29 what? What? 86? 46. Typically, I'll write all of them, but I don't care if you write down 2. Don't write down 0.3. Okay? Don't write down 0.3, but 0.29 will work, 0.295 will work. Go ahead, talk. You bet. So your answer to this problem is the probability, and you could do either one, right? That x was less than 6 is equal to 0.2946. And that would be perfectly acceptable for the answer if you showed the graph, you showed the work, and you put this answer. If you didn't want to put that and you wanted to put the probability that z was less than, what was it, 0.54? Negative 0.54? That's okay also. Either one of those two are fine. If you want to put both, put both. At some point on your paper, the grader needs to see that you turn this number into this number, and this number is a z-score. So all I do is just go over here. I typically write this one right here, and I do the 6 minus 6 point whatever, or the 1 point whatever, and I'll put negative 0.54, and then I'll put that answer. Draw the picture, show the work, put the answer. Oh, what was the question? That's what we gotta do next, right? What proportion of these 7th graders will have a vocabulary scores that are below 6th grade level? And you should always do what? Put the answer in context. Sorry, I forgot what it was. 29%? About 29% of the 7th graders in Gary, Indiana scored below 6th grade reading level good enough. What does it say? We estimate that about 29.4% of Gary, Indiana 7th grader scores fall below the 6th grade level. That's pretty good. How we doing? Pretty good. We're doing really good. I may have went too fast. I don't know. I may have went too slow. Questions? What to write, what you need to write, what you don't want to write. O-T-I, how I love thou. So if you don't want to use table A, you would use your calculator because table A becomes confusing. Table A, listen to me, only finds the area to the left. Table A will not find the area to the right. So if I wanted greater than 6, I would have to do the same thing, and I would look up that 0.29, and then I would have to subtract that 0.29 from 1, because 100% falls underneath it. Let me kind of show it up here. Got so many things in my hand. I found this area. I want this one. So 1 minus this will give me this area. And it's blue, so I gotta hit second in this. And if you have a different calculator than this, I might need to show you individually, but I know most of you have TIs because they did a better job of marketing than any other calculator. Normal PDF, you will never, ever, ever use. Do not ever, ever use it. Delete it off your programs if you can, but you can't. But you will never, ever, ever use it. I'm not even gonna tell you what it does, because I didn't know for the first 15 years. Normal CDF is what you're gonna use. That's a cumulative distribution frequency. I don't know, I'm making all that up. Normal CDF. Now, depending on which calculator you have is what's going to happen next. If you have a really old calculator, it's just going to say normal CDF and it's going to open up a parenthesis. If you have a relatively newer calculator that's been updated, it's going to ask you questions like this. If it doesn't ask you questions, you just write this same stuff, but you put commas between it. The comma button is just above the 7. If you need anything, please let me know. Some of you, I might just need to update your calculators because most of them will do this now. It's only the old 83s that won't. Lower bound, that's where we want our information to start. In this particular case, it's like negative infinity because we want less than 6, correct? So we want less than 6, which is all the way out there, which is negative infinity. I can put negative 99999, and that's pretty close. In fact, I probably can come pretty close just to putting negative 9. Because 3 is almost all the information anyway. Fair enough? So just put something pretty small there. That's plenty. If you put more than that, you're gonna get the same answer I get. Upper. Now this is where the uh-ohs change. I can put one of two things right there. I can put, what was the z-score? Negative 0.54? Is that what it was? I can put negative 0.54 and the mean will be 0 and that will be 1 because that's the standard normal curve. And so if I go down here real quick and I hit paste, those of you with the calculators, that's what yours are going to look like with the commas. Enter. There's that 0.2954 that we just found. Now, your calculators are really smart lately, and we can do distributions, and we can actually go normal CDF, and we can go negative 9999. Now we probably need, but we can go to 6. And now the mean is now it's not 1.55, what was it, 6? What was the mean?
6.84.
Thank you. 6.84, and this was 1.55. Y'all okay? Kind of see? I hate it because that gives you the same answer. And I hate it because some of you guys say, well, my calculator does it, why can't I just use my calculator? And you can, but it hasn't explained anything that you know what you're doing. You have to explain to the grader, one, that you understand that there's a z-score involved, and you need to understand how to explain it, how to do it. Now, if you do all this stuff and still write it, you're okay. Never, ever, ever, ever write calculator talk on your test. A grader does not know how to read calculator talk. So there's no reason to ever put normal CDF. Y'all okay? Because it doesn't we know you used your calculator or you used your table. You wouldn't put use table A and find this. You would just put it. So don't put normal CDF and then put it. Just put the value. Yes, no, maybe. Talk to me.
So like, would they give you table A?
So table A is part of your formula sheet, yes.
Oh.
Yes, table A is part of your formula sheet. And I got those coming for you guys. So each one of you will have a formula sheet along with table A. Question else? Good one. You're gonna have to use table A or your calculator. I recommend your calculator. And if you wanna plug it all in, that's fine. It doesn't matter. You're okay. Table A will not find the area to the right. Your calculator can. I can put normal CDF, and I can go from 6 to infinity. Your table cannot do that. Your table can only go to the left. My guess is that better be the opposite of that. This plus this better be 1. And it is. Questions so far? You'll get plenty of practice. Plenty of practice. Don't ever use PDF though. Don't use PDF. It's going, if you even hit it, it's going to ask you something else, like the X value. It doesn't give you a range. So if you put 6 and you put, what was it, 6 point, I already forget, 5.4? 8.4, close. And you put 1.55. It's not 22%. So don't use PDF because you didn't tell it even where to go. You just gave a value. Yep.
So this is, like, this works for like the normal standard curves?
Yes.
So, like, basically.
Any one of them. Yes. You nerds like me that have had calculus could figure out the or what the equation of a normal curve is. It's a crazy equation. And you can find the integral from here to here, and it will give you that same 0.29. If I'm speaking anything to you guys that have had calculus.
Is there like a spin equation that you?
There is. You have to look it up. I don't remember what it is. It's got an e and an exponent of a square root. It's ugly, but there is one for a normal curve. I have one that does it every year just because they like math, and I think it's pretty cool. But anyway, we don't do all that stuff. We just use normal CDF, which does the same thing. It does the same thing. But those of you, if you put the equation right here and you did the integral from here to here, that's what your calculator's doing. It just does it all behind the scenes. Any questions so far? We got one more thing I gotta show you. I'm doing pretty good. That's the only example I go over, and I hate it because it's not a great one. But I want you to make sure that if you're using your tables, remember that the tables only go to the left. And so if you gotta go to the right, what's really helpful is if you wanna find it between two of them. Let's sidebar for just a second. I could do this. The calculator really helps you on this. And I don't use tables. I use the tables for one thing, and that happens in chapter 12 or 11 or something. It really helps you if you want to find the information between here and here. Let me get this up and get going because I want to be able to put it on the board. Talk to me. Yeah. Don't need to ask. Just go. Just don't tear anything up. Knuckleheads. Good gracious, show up. No, you know what my pre-calc kids have to sit through. It really helps when I do this. I may have froze it. Nope, there it is. There it is. Okay, finally, sorry about that. Last time I'm gonna ask, 6.84? If I want the data between 6 and 7, picture this using your table, right? You gotta find this on your table, then you gotta find this on your table, and you gotta subtract this from this. And that will give you that area. Your calculator, you can put 6 and 7. Fair? So your calculator helps you quite a bit. Because you don't have to try to figure out if the left, right, subtract this from this, and that, it just poof. I'm gonna go from here to here.
But if it was on like an open response, you would have to like
So if it's an open response, you'd wanna turn the 6 and the 7 into z-scores. And then, I don't care if you use the z-scores in your calculator or the 6 and 7 in your calculator.
So what would you say, like, after you find the z-scores?
So after you found the z-scores, here, I would just show it. Z equals 6 minus equals this, z equals, fair? And I just show that information, and then I would have the probability. And again, I think what's really cool is if you guys did the probability that z is less than but greater than this, and say it's equal. But if you went ahead and said the probability that x is less than, 7 and 6, you're okay also as long as you showed that you turned it. And truth be told, as long as you show the picture, you're pretty good. But they wanna know what the mean is, they wanna know what standard deviation is, and if you do all the things I've showed you, you've covered your bases. There are things that you can cheat by and show less, as long as you show everything on there. And you don't always know what the rubric says, but a picture just, as long as I do this, I've covered darn near everything already. I think this will get you a P without doing anything. Now, if it's if it's multiple choice, I would go right, and I wouldn't do anything, right? I'd punch in 6, I'd punch in 7, I'd punch in the mean, punch in standard deviation, answer it, done. Because you're not gonna get any credit for multiple choice for getting it right or wrong other than getting it right. So hopefully that makes sense what I'm talking about by the table. Okay, very good. One more thing I need to show you guys. Uh-oh, I don't want that, I want this. Aw. Oh, here we go, here we go, here we go, here we go. Here we go now, here we go now. Beautiful. Click. Click, click. Sometimes they want to know what percentage of a value and where that falls. So rather than knowing the percent or finding the percent, sometimes they give you the percent, we want to know the value. So sometimes we want to work backwards. Everybody okay? The process is going to be the same thing. You're still going to draw a picture, you're still going to show your work, and you're still going to answer in the context of the problem. So that's still going to stay the same. I don't think we need to even write it again because it's just going to be the same. Every time, draw a picture, draw a picture, draw a picture, show some kind of work, put the answer. Click. According to the CDC, which I'm sure nobody's ever heard about, the heights of 3-year-old females are approximately normally distributed. Whoop, stop. Pin, back. Approximately normally distributed. I stop right then. Oh, I don't like that at all, but that's what it is. With a mean of 95 point, oh, dang it, dyslexia got me. Oh, go back. Oh, that's okay. 94.5 and a standard deviation of 4. 75% are taller than nope, that's the wrong way. Fair? Y'all see what I'm getting ready to mess up on?
Yeah.
I was getting ready to put 0.75% in here, and that wouldn't be 75% of taller than, that would be 75% are shorter than. Four. Beautiful drawing. That's what some of you guys look like. I haven't seen them yet, but I bet it is. Sloppy pieces of crap. So, here's what we're gonna have to do. The problem is now, I don't know the X value, but I know that this is 94.5, and I know that that's 4. And I don't know the Z-score. It's not 0.75. That's not the Z-score. 0.75 is the percent I get from the Z-score. Fair? So I've got to find the Z-score for 0.75. What the heck happened there?
Top left. No, click the back arrow.
I think it's this one though, is what I want. Working backwards. If you're using table A, this is brutal. You gotta find 75% in here. $74, 86, 75, 17. There's not even a 75. Kind of makes sense? But my guess is it's gonna be 0.67 and a little bit more, but 0.67 will work. Fair enough. That's the Z-score for 75%. 0.67. So this will be oh, come on, turn it back to a pencil. 0.67. If you want your calculator, which you do, go to your distributions. We don't ever use PDF. CDF is what we use to find a percentage. Inverse norm. Okay with that? Inverse norm. Enter. This is where the new ones really come in handy, because some of them don't even do the left, center, right. Yep. Say again? That's a second distributions inverse norm. Inverse norm. Whoops, clear. Don't put it there. 0.75. Y'all caught up? You good?
Mine doesn't have that.
Okay, yeah, most of them don't. So you're just gonna put in 0.75 and hit enter.
Where?
After you do inverse norm? Does it just open up a parenthesis?
Just kidding.
Are you okay?
I was on minus C.
Oh, okay.
It keeps taking me back to minus C.
Yeah, you probably have to clear all the way out, exit out. I leave this 0, 1, because 0, 1 is gonna give me the Z-score. 0, 1 will give me the Z-score. If I turn that to whatever the mean and standard deviation is, that's going to give me the answer without showing a whole lot of work. Makes sense what I'm saying? Now, you can do that if it's multiple choice, and it will be fine. Now, again, my calculator asked me for the left, center, and the right. I want 75% to be to the left. 0, 1, paste it. Some of you don't have the left, right, don't worry about it. If you want it, then let me update your calculators. I think only the CEs will do it.
Wait, does it matter if we don't have it?
Now, if you don't have it, it does it to the left.
Okay.
Good question, I'm glad you asked that.
Will we use it to the right?
You could. But here's what it is. If you want 75% to the right, you'll do 25%.
Then you could do 25% to the left, right?
Yeah,
Okay.
yeah. Y'all kind of hear that, right? So it's not that hard to change that up.
Wait, so why is it to the left? Because we're taking 75% from the right, aren't we? Like 75% are taller than.
Oh, am I doing this wrong? I am, aren't I?
100% to the left?
What?
Or no,
What?
no,
No, it'd be 25% to the left.
Yeah.
So I'm doing it, I'm doing what I was originally going to do.
Yeah, you're right,
Yeah,
yeah.
this is, so I do want 25% to the left. I'm glad you caught, thank you. First mistake this year. My year just started. Okay, so I do want 25% to the left. There's that. Is that the right Z-score? Yeah, that is the right, I want it negative.
Yeah.
Guess what happens if I put in 0.75?
As long as it's on.
I'll get 0.67 because they're mirror images of each other. They're mirror images of each other. So that's the Z-score. And that's what I should do to show the work. Just put that Z-score down. The best thing now is to go back to your calculator and do it all with the values. But you guys, this is why you need Algebra 2 for this class. I'm being funny. Oop, went too far. Sorry. Because in Algebra 2, you have to multiply both sides by 4, and then you gotta add the 95.7 or 94.5 to the other side to get x by itself. But if you want your calculator to do all the work, let your calculator do all the work and change the 0, 1 to 94.54, and that will give you the x value. I said a lot more than I wrote down. And I'm glad you guys asked the questions if you did, because you gave me some different scenarios of making sure that I do things correctly. The biggest mistake students do is they do the wrong side, they go the wrong way. And when you do your homework, you'll see that sometimes, and oh yeah, I'm supposed to use this. Sometimes you may have to do 2 Z-scores because they might want the middle 80%. Think about that, the middle 80%, that's where the new calculators come into play, because I can just do the center and it will give me both Z-scores. But your table, you can't do both, so if I want the middle 80%, I need the bottom 20% and the bottom, no, I need the bottom 10% and the bottom 90%. Because 80 leaves me 20 left over, or 10 on each. Your homework will give you a lot of practice at this. And I have several worksheets that will give you a lot of practice at this. But I want you guys to be very, very comfortable at finding the area as well as finding the values from the area. Because I think that's a very, very big deal in statistics. Draw it, show the work, make sure you answer it. 75% or 91.8, I didn't find the answer. But that was the end of it. I know there will be questions that arise. If you guys are working on that this weekend and you get stuck on something or you really can't find it, the book does a really horrible job when you guys hit help. This is the wrong answer, most of the time. The correct answer is it. That doesn't help me any. So if you need something, make sure you send me a remind text, send me an email, do something, especially if you're working right then. Now, I'm not always gonna be able to get back to you, but Monday, we're gonna be able to work in class too. So I'll have some worksheets for you, so if you don't wanna do anything this weekend, that's fine. If you're worried about not being able to catch up, then do some this weekend. But Monday, we're gonna work. I still don't know when we're gonna test. I don't think we're gonna test Wednesday. I'm probably just gonna end up giving you a quiz on this stuff. And we'll just do like half of it and continue on. That's what I'm kinda thinking in my head. It's just 2 sections, maybe even a take home. Heaven forbid if I try to boost your grade up. Some of you don't need it, a lot of you don't. But, all you can worry about right now is Monday. So Monday pretty much is gonna be a work day, and I'm gonna have several worksheets for you guys to do, as well as you can work on your homework, and then you can relax this weekend if you want, whatever you guys need to do this weekend. But if you wanna work on some stuff, go ahead and work on it. Cause like I said, I will have worksheets for you, and you don't want it all to build up, but some of you will be fine. If you do not have a calculator, you need to get one. You need to get one. Because I told you, you will not be able to survive in this class without a calculator. You will not be able to survive this class without a calculator. We're only touching a little bit what we're gonna do. The entire second semester, the entire work can be done on the calculator. All you gotta know is how to do is punch it up. And that gives you all the work you wanna do. So you gotta have one. If you got a calculator you're not too sure about or don't know how to work, or you want it updated, let's work on that on Monday. end. Stop.